today we're going to be investigating the idea and concept of period of a graph. And first of all, we're going to be taking a look at this cosine graph. And I'm going to show you what the period visually looks like. So let's go ahead and use blue. I'm going to start at this point. I'm going to trace the graph down and then all the way back up to the top of what we'll call the next ridge. So notice how we started at the top of a ridge, went down, and then went to the next ridge, just like going down and up a hill. Now the period is going to be the distance between these 2 points. Okay, so this hints at the definition of a period. Let's look at another graph. We have another cosine graph here. This is 3 cosine of 2x. Again, I'm going to trace. Now you can start at any point in the graph. I'm going to start at the top of these waves because that's the easiest point to identify. And I'm going to trace until I get to the top of the next wave. Okay, and again, the period I'm going to mark as the horizontal distance between these 2 points. So I'm kind of giving away the definition of period here. Okay, notice what that is. You can see kind of what that is if you were to move this red line down to the x-axis. Okay, finally, let's look at a sine wave. And by the way, the period for sine and cosine you're going to see is there's a relationship. Let's just put it that way. Okay, so let's choose 2 points on the sine graph. Now, in this particular case, I chose to pick the middle of the wave, and that's fine. It's not going to change the concept of periods. I'm going to start and trace along the wave until I get back to the middle of the next wave. Okay, so I went what you could call one full cycle, and again I'm going to mark the period of this graph as the distance between 2 points. And here you can see, get a good idea, it starts at 0 and goes to 2 pi. Okay, so that is the period represented visually. Now let me ask you, what is the definition of period? Well, this is what I have. You might have come up with something else. It's the distance it takes for the graph to repeat itself. In each of these cases, it took this horizontal distance, and let me go ahead and put the word horizontal here. Okay, the horizontal distance it takes to repeat itself. Notice that in each case, this red line is the horizontal distance that it takes for the graph to repeat itself. And as I said, that distance is going to be the same no matter which 2 points you pick on the graph. Okay, for example, I can take this same red line and move it down here, and I still see that I'm in the middle of the wave here, right? But it still takes that same distance to get to the middle of the next wave. And I can move this red line wherever I want, and that illustrates how long the horizontal distance it takes for the graph to repeat itself. That's the best definition that I have for you for the period of a function. It's the horizontal distance it takes for the function to repeat itself. I do say graph, but of course the graph is the graph of the function. So let's look at sine. Okay, this is the graph that we just looked at, f of x equals sine. Notice that to find the horizontal distance numerically, you would do 2 pi minus 0. You would subtract the x values where the y values not only are the same, but where the y values the graph repeats itself. Notice that the y value equals 0 here as well, right? But pi would not be sufficient because the graph doesn't repeat itself. It's going down at pi and it's going up at 0. So it takes a full 2 pi for the graph to repeat itself. Okay, so therefore numerically, since I get the same y value of 0 at those 2 points and the graph repeats itself, I just subtract these two x values, 2 pi minus 0, to get 2 pi. Now notice I have the absolute value bars here. That's because absolute value represents distance, and sometimes I might get a negative number back when I subtract two x values, especially when we're doing proofs and that kind of thing. And that's okay, because if I take the absolute value, that will give me the distance between those two x values. Here's another reason why it takes 2 pi for the graph to repeat itself. Look at the y values here as we start at 0 pi. Okay, here's, these are the y values. 1/2 square root of 2 over 2, square root of 3 over 2, then it goes back to square root of 3 over 2, and they're all positive, right? They're all positive in the first and second quadrant. And moving past pi, they become negative, okay? So I have not After pi, I have not started the cycle again. The y values, which are the sine values, don't become the same again, okay? I have to go all the way back around through the third and fourth quadrant before I get back to the same y value. So I have to go past 2 pi. Now notice at 0, pi at 0, and then once I go all the way around, I'm back at 0 again, and I start to go back to the same y values after 2 pi. That's the reason why the period of sine is 2 pi. And we'll look at the same thing for cosine. So this is the numeric proof that the period of sine is 2 pi. Here's another way to prove it. If f of x equals sine of x, and now know that f of 0 is equal to 0, and f of 2 pi is equal to 0, okay, and that's where the graph repeats itself, then I can show that the period is just the distance between these two x values, 2 pi minus 0, which is 2 pi. Now, here's the next question we're going to address. What happens if I put a 2 here in front of the x? What would happen to the period? We will address this answer in the next video.